Hi, Algebra 2 scholars. I want to remind you of something we talked about, I think, last week. It was some special right triangles. And it was an introduction to these special right triangles where I showed you where these came from. So if we have a square with sides 1, we cut it in half. That gives us a right angle there. We know that the legs are 1, and so if we use the Pythagorean theorem, that gives us a hypotenuse with a distance of root 2. Similarly, if you have an equilateral triangle of sides 2, and you cut that directly in half like this, so that it's got a perpendicular, then this side down here is 1. And we know that an equilateral triangle has a measure of 60 for each angle, which if this is 60 and this is 90, that makes this 30. So we noted that if we have a hypotenuse of 2 with one leg of 1, then that makes this length root 3, which is about 1.732. Another thing we noted was that the hypotenuse is always across from the right angle. And this one being an isosceles with two of the same angles, both of those are 1. So in the 30, that's the 45, 45, 90. In the 30, 60, 90, we notice that the 1 is always across from the smallest angle. Smallest side, smallest angle. So now we have these special right triangles. So I am referring to a 45, 45, 90 and a 30, 60, 90. Those are our two special right triangles. Now, what we're going to do with these special right triangles is we're going to try to relate them to the unit circle. Remember, our unit circle is a circle with radius 1 that is centered around 0, 0, the origin. And so it would look like this, where here would be my x and my y, and this would be my radius, a radius of 1, be like that. There's where our unit circle similarity comes. So this point is 1, 0. Okay. If we drew a 45, 45, 90 within the unit circle, it would look like this. In other words, we start with our special right triangle, the sides of 1, 1, and root 2, and then we can use similar triangles to label the same exact triangle because it's in the same proportions, where I take the root 2 and I divide it into all these sides. Hopefully you can see that that is the same. So it starts out with my special right triangle, and then it goes to my unit triangle. And you can see the work I did. This means that if you divide all sides by root 2, you get the similar sides. This tells me that in this triangle, cosine of 45, remember cosine is adjacent over hypotenuse. Cosine of 45 is adjacent over hypotenuse. And also sine of 45 is opposite over hypotenuse. So they're both going to be 1 over root 2. Remember, we need to rationalize it. And so we get that that length is root 2 over 2. Now, the neat thing about the unit circle you should be able to tell here is this point that is on the unit circle is root 2 over 2 for an x value, because it's this far along the x, and root 2 over 2 for the y value. Now, if you look at the unit circle that we did last week with the paper, you'll notice that where it has 45 degrees, at that red dot it says root 2 over 2 right next to it. And then you'll be able to do that right triangle on any of the 45 degrees in the unit circle. We'll get to that in a minute, but if I were going to sketch it, it would also be this one, or it'd be negative 45 degrees. It'd be this one here, which is off the screen, or that would be 45 degrees, but it'd be over there at 135, and then of course you'd have your fourth quadrant also. So 45, 45, that gives you 4 of the triangles already. The object being that you're going to be able to produce these and memorize them on your own. So next, if we look at the 30, 60, 90, I started out with the picture on the right with this special right triangle. It's just sideways, but in the first slide it was straight up where the 30 was on the top. But you see again, the 30 is directly across from the 1. Oops. And the root 3 is across from the 60. The 2 being the biggest number is across from the hypotenuse. If you divide all of these on the right sides by 2, you will get exactly these proportions on the left. So these are similar triangles. Okay. One thing I want you to do is always associate the x with cosine and the y with sine. And so here are the 6 sides, the 6 trig identities, if you were going to figure them out. So for cosine 30, it's adjacent over hypotenuse. Okay? And then for sine 30, it's opposite over hypotenuse. Tangent then, of course, is opposite over adjacent. And just like the last slide, if we have 1 over root 3, we rationalize it to get root 3 over 3. So that's how you get that. You get all these, and you'll notice that those are the same by that. But if I have to take this same similar triangle, and I want to relate it to the unit circle, remember my unit circle is always where my axes, this is 0, 0. This is on the unit circle where it crosses at 1, 0. And if you were going to look at this triangle, this is the flat one in your foldable thing, well, this is root 3 over 2 far over. So if you were going to tell me what this point is, well, it is root 3 over 2 on the x, and it is 1/2 on the y. So you can tell me right here immediately, if I ask you, what is the sine of 30? Well, the sine of 30 is 1/2, because we associate it with the y. Sine of 30 is 1/2. You can also tell me the cosine of 30. Let's say we want the cosine, then here's your 30. The x value is root 3 over 2. That's the cosine of 30. So you could do this and learn all of these angles without a calculator. That's the purpose. We'd really like you to be comfortable with all of these. Now this same triangle, you can put it the other direction also. You can put it this direction so that instead of 30 here, okay, you can look at this one where now my middle angle is 60. This is 1. This one's 30. And so if you go across from it, this side here is only 1/2, and this side here is root 3 over 2. So the point up here is 1/2 and root 3 over 2 because they're exact opposite. You're just changing the way the triangle looks. So again, you can find any angle you want on this unit circle. So we're going to do some more practice with it. This next slide I wanted to show you just so that you could see, if you have your paper unit circle in front of you, where I drew in blue, the 45, 45, 90, that's that middle triangle that can be spun. You can spin it all the way around, but wherever you spin it, you can see that that point there is root 2 over 2, root 2 over 2. If you were going to put it, say, over here, your middle central angle is still 45. Okay, so this point here is going to be exactly the same, except now your cosine's negative. That's all, because you went on the negative x-axis, but your y is still positive. Okay, so say you want to draw the one down here. Now you're all the way here, but still it's a 45, 45, 90. So this angle here is simply negative. Okay, and then finally, of course, you can do the same for here, where it's 45, 45, 90, and you should be able to tell me immediately the first one, or the x, is positive, and the y is negative. So the cosine is positive, and the sine is negative. So I was hoping that this picture would show you that's what it looks like if you have this triangle. Moving on, if we look at instead the 30, 60, 90, I'm hoping that you can see where it's the same unit circle. I have 0, 90, 180, and 270 marked. But the little green triangle shows you that the first number in that coordinate is the cosine, or the x. It's root 3 over 2. Okay, because right here is root 3 over 2. And then if you want to know the y value, that's the sine, that's 1/2. It's the shorter side. It corresponds to this triangle that we did before. If you wanted to look at the other one, meaning the one going up and down, okay, so this one here, again, the hypotenuse is 1, but if you want to know how high that one is, it's root 3 over 2, and that's your sine value, or y. And this one here is the short one, which is 1/2, and that's your x value, or cosine. And of course, again, you can do this for each one, so you could have a 60 here. Okay, that's the short side, so it'd be negative 1/2. And positive root 3 over 2. Sorry about that. Again, you have another skinny one here. It's negative 1/2 negative root 3 over 2, because we're in the fourth quadrant now. Here's another one, the short skinny one, and it's going to be a positive 1/2 for the cosine and a negative root 3 over 2 for the sine. So the tall skinny ones can look like that. You can probably see what the other one's going to look like. So if here's your 30, 60, 90 on your triangle, then here's your short one. This is your cosine value, and this is your sine value. There's your unit 1 sine value, cosine value, and with hypotenuse, this is your sine value, and that's your cosine value. So you should be able to reproduce this circle on your own, and that's what we're going to practice next. Now that you know what a reference angle is and you know which direction to go, you should be fairly comfortable with degrees versus radians, and both of them are marked on your circle. And so we're going to, like I said, go with this, and then you're going to be filling in the chart, just hopefully by being able to follow these notes and using that circle. And eventually, hopefully by next year, of course, you will be able to, in your mind's eye, see, well, what is cosine of 30? You can picture that triangle in your mind, and you can tell me what the x value at that angle is. So that's all for now. Yeah, we're going to be doing, like I said, I'm going to post this worksheet, and you're going to fill it out. And remember, Tuesday mornings, 10 to 12, Mr. A and I will be live on Teams for any kind of help you need. Okay, good luck.